Welcome to this explainer. Look, today we are going to crack the absolute code on Cambridge AS and A-level mathematics. Specifically, we're zeroing in on syllabus 9709, and we are tackling a topic that literally makes or breaks exam papers across the globe, the coordinate geometry equation of a straight line. Now, if you've ever felt like you know all the formulas, you've memorized the textbooks backward and forward, but you still aren't getting those top marks, you are in exactly the right place. To understand why this happens, I want you to picture two types of students. Let's call them Alex and Sam. Alex is the overloader. Alex hits a coordinate geometry question and just dumps raw mathematics facts onto the page, every formula they know with absolutely zero analytical structure. Then you have Sam. Sam is the rusher. Sam sees a question, panics about the clock, and completely misses the specific command word requirements, losing easy marks left and right. I've looked at countless past papers, especially the infamous Code 5080 papers that lead up to this level, and when you put Alex and Sam's flawed answers side by side with the examiner's red pen marks, it is a bloodbath. Today, we're going to transform those red marks into green check marks.
Okay, let's establish our stakes right out of the gate. This quote right here is from a recent Cambridge senior examiner. They said, the difference between a B and an A star in mathematics often comes down to how well you understand coordinate geometry. Let that sink in. Achieving those top-tier marks isn't just about whether you can solve for X. It is about a deep analytical methodology. The examiners aren't just looking for a final number at the bottom of the page. They are looking at exactly how you think. They want to see you build bulletproof arguments with stress-tested evidence and impeccable quality control. If your foundation in coordinate geometry is shaky, the whole house comes down when you get to calculus or complex vectors later on.
So how do we get you thinking like an A-star student? Well, here is our tactical playbook for today's session. First, we'll cover the foundations of coordinate geometry. Second, we'll reveal the step-by-step methodology. This is where we'll introduce our mathematics success blueprint. Third, we are going to dive into the top 3 examiner warnings. And finally, number 4, the method mark lifeline. We have a lot of ground to cover, and we're going to be applying strategies that work across the board. Whether you're building up from IGCSE 0580, pushing through additional math 0606, tackling O-level 4024, 4037 or 4040, all the way up to the heavy-hitting 1979 syllabus.
All right, let's jump right into Section 1, Foundations of Coordinate Geometry. This is where we separate the average test taker from the top-tier mathematical thinker.
There is a massive contrast in how students study for this exam. Think back to Alex, our overloader. Alex relies on superficial breadth. That's the standard approach, right? Trying to cover a ton of ground, memorizing y equals mx plus c, but completely lacking conceptual links. But the Cambridge Assessment Framework doesn't reward that. It heavily prioritizes analytical depth. To get those top marks, you must demonstrate a connected understanding that transfers effortlessly to entirely unfamiliar contexts. You can't just know the what, you have to understand the why and the how. When they throw a curveball question at you involving perpendicular bisectors intersecting with a circle, superficial breadth will leave you completely paralyzed. Analytical depth gives you the tools to break it down.
And that deep understanding is what we call your theoretical architecture. This is the absolute bedrock of coordinate geometry. It doesn't just rest on knowing the formula for a gradient. It rests on precise definitions, understanding causal relationships, and seamlessly integrating this topic with other areas of the 9709 syllabus. Principal examiner reports explicitly highlight that referencing these cross-topic connections is exactly what earns candidates those significantly higher marks. It's about seeing the matrix. When you understand that a gradient is basically a rate of change, suddenly you're not just doing coordinate geometry. You're setting yourself up for differential calculus. You're building a structural framework that examiners love to see.
So, if we know that theoretical architecture is the ultimate goal, it begs a really important question. Why do students find applying concepts to unfamiliar contexts so incredibly hard? Well, remember Sam, the rusher? It's a classic trap. You learn the equation of a straight line in a simple, perfectly packaged classroom scenario. But then, the exam hall hits you with a complex, multi-layered problem wrapped in confusing language. Top students overcome this hurdle not by cramming harder, but by encoding their learning deeply and systematically decoding the command words.
To help you encode these concepts deeply, I want to share a fantastic meta-learning tip. Use a visual story method to encode complex coordinate geometry concepts. Don't just look at a straight line equation as a jumble of letters and numbers. Create a visual narrative in your mind. Imagine the y-intercept as your starting anchor on a cliff face and the gradient as the specific angle of your climb. By visualizing the mathematics, you anchor these abstract concepts firmly into your memory, making them instantly accessible when you're under pressure. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, the strategies we share weekly are game changers.
All right, now that our foundation is rock solid, let's transition from theory to practice. Section 2, the step-by-step methodology. It is time to unveil how top students structure their mathematical arguments.
This is your deconstruct, solve, evaluate procedural framework. 5 steps. Step 1. Deconstruct the question. This means decoding the command words. Does it say hence, show that, or find? Those words dictate your entire strategy. Step 2. Extract relevant data. Pull out your coordinates and gradients. Step 3. Select your analytical framework. For top-tier students, this is where we adapt the Peel framework. Point, evidence, explanation, link. For mathematics, your point is stating the mathematical principle you're using. Your evidence is the data you extracted. Step 4. Execute with clear notation. This is your explanation, the actual algebraic manipulation. And Step 5, the link, which everyone skips. Evaluate and check for reasonability. Does your answer actually satisfy the command word from Step 1? This loop guarantees you are answering the question they actually asked.
As you execute those 5 steps, your essential presentation conventions are completely non-negotiable. This is the core of our mathematics success blueprint. You need to use proper headings, ensure clear annotation, apply correct terminology, and maintain appropriate formats. When the clock is ticking down and you are rushing like Sam, it is so tempting to just abandon clear presentation and scribble numbers everywhere. Do not do it. Following these strict conventions demonstrates the professional, logical reasoning skills that examiners are actively looking to reward. If an examiner has to hunt for your answer, you've already lost the psychological battle.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's dive into Section 3. Top 3 examiner warnings. We are pulling direct insights from principal examiner reports on exactly what not to do. Out of all the feedback given by Cambridge examiners year after year, there are 3 critical mistakes. These 3 traps repeatedly cause students to hemorrhage marks on straight-line equation problems. We are going to deconstruct them right now. Let's turn this into a quick interactive workshop. I want you to mentally scan this data table. Challenge 1. Spot the chord trend. What's the common theme here? It's all about losing marks due to poor execution, not just bad math. Mistake number 1, using the wrong approach for the specific context. This is what happens when you don't decode command words. Mistake number 2, formatting, forgetting to check the overall presentation. That's Alex, right there, dumping facts with no structure. And mistake number 3, lack of specificity, providing generic answers instead of evaluating alternatives and justifying your approach based on the exact context given. If the question asks for the equation in the form ax plus by plus c equals 0 and you leave it in y equals mx plus c, you are throwing away points. Don't be that candidate. Which brings us perfectly to our final core concept today. Section 4, the method mark lifeline. This is your ultimate exam survival strategy when things don't go perfectly according to plan.
Understanding how Cambridge marking actually works behind the scenes can literally save your grade. The method mark strategy is a scoring principle where marks are awarded for demonstrating the correct mathematical process, even if your final numerical answer is dead wrong. Let's do a speedwriting challenge in our heads. Imagine you have 30 seconds to write down the formula to find the distance between 2 points. If you write that formula down clearly and substitute the values incorrectly, but then mess up the very last bit of arithmetic, guess what? You still get marks. Examiners explicitly warn that students lose vital, easy marks simply by doing the math in their heads and not showing they're working.
Look at the massive difference here. Consider the danger of a hidden process. If you do the math in your head or scribble it out on rough paper that you don't hand in, you lose all your method marks. You are carrying a massive, unnecessary risk if your final answer is wrong. Compare that to a visible framework. By clearly writing out your logical steps, using that adapted Peel framework we discussed, you secure those method marks. It acts as an insurance policy. It's a key part of the time management matrix. Spending an extra 10 seconds to write your steps clearly salvages points regardless of a minor, silly calculation error at the end. Always make your analytical framework visible on the page.
So, as we wrap up this explainer, I want to leave you with this provocative question. Have you rigorously evaluated your final step and checked for reasonableness, or are you just rushing to the finish line like Sam? Let this guide your exam practice, because mastering the process, decoding those command words, and utilizing the Peel framework is your true blueprint for Cambridge success. Listen closely. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.